Hi everyone, this is a problem on mixing a strongly acidic solution of known pH with a strongly basic solution of known pH in order to obtain a neutral mixture. So the problem states that volume A milliliters of a strong acid solution of pH 2.0 is mixed with volume B milliliters of a strong base solution of pH 11.0. Express volume A in terms of volume B if the mixture is neutral. The solution temperature is 24 degrees Celsius. So right away, one of the key details of this question is the fact that the mixture must be neutral. And so what that tells us is that eventually, whenever they're mixed, a neutral mixture will have a hydronium concentration equal to a hydroxide concentration. So let's get to the problem. We're going to use the pH and the pOH of each solution to determine the molarity of hydronium and hydroxide, since we mentioned that they must be equal for the solution to be neutral. The formula for pH is pH equals negative log of hydronium concentration. Therefore, the hydronium concentration will equal 10 to the negative power of the pH. So using the values that the problem provided us, 10 to the negative 2.0 equals 0.01 molar hydronium. And for the basic solution, instead of the pOH, we're more interested in the pOH. And so in order to obtain the pOH, we use this formula here. pOH equals 14 minus the pH. And so pOH will equal 14 minus 11 in this case, which equals 3. And similar to the formula for pH, pOH equals negative log of the hydroxide concentration. Therefore, hydroxide concentration equals 10 to the negative power of pOH. So using the values that the problem provided us, we find that 10 to the negative 3 will equal 0.001 molar hydroxide concentration. And so what do we do now? Now that we know the molarity of each the hydronium and the hydroxide ions, what should we do next? So we have to remember that the problem stated that the mixture will be neutral in terms of pH, which means that the molarity of the hydronium and the molarity of the hydroxide will equal each other. So what we'll do now is we will write the equations for the molarity of each of the solutions. So the molarity formula is molarity equals the moles of solute divided by the volume of the solution in liters. And so starting out with the strong acid solution, we find that 0.01 molar equals N moles of hydronium divided by volume A, which is the volume of the acidic solution that we'll be using. And this 0.01 molar value is what we calculated in the previous steps. For the strong base solution, we follow a similar process. 0.001 m equals N moles of hydroxide divided by volume B, which is the volume of the basic solution that we'll be using for the mixture. And once again, the very important detail here is that for the solution to be neutral, the number of moles of each hydroxide and hydronium must be equal. So that means that this N variable that you see in both equations of the molarity, they are going to be equal in value. So to say that again, the moles of hydronium will equal the number of moles of hydroxide, which equals the variable N. And so now that we know that the number of moles of each ion must be equal, what we're going to do is we can isolate that N variable in order to equate the two molarity equations. So taking the molarity equation that we came up with in the last step, for the acidic solution, 0.01 molar equals N moles of hydronium divided by volume A. In order to isolate N in this equation, we'll multiply both sides by volume A, and we find that N will equal volume A times 0.01. And then we follow a similar process for the molarity equation for the basic solution. So 0.001 molar equals N moles of hydroxide divided by volume B. We'll multiply both sides by volume B in order to isolate N, and we find that N equals volume B times 0.001. And so now what we can do is we can actually equate these two things. Since N equals N, what that means is the acidic solution expression, N equals volume A times 0.001, that equals N, and something else that also equals N is volume B times 0.001, which means we can equate those two expressions. Volume A times 0.01 equals volume B times 0.001. So what we can now do in order to answer the question is we can isolate the volume A variable. And how we'll do that is we'll rewrite this equation in terms of volume A by dividing both sides by 0.01. And we find that volume A equals volume B times 0.1. And to say that in another way, that means that volume for every part of volume A you will have 10 parts of volume B. And that is our answer. So I hope this helped you.